So at long last, we can take a look at how the test driver is implemented, and we can also run everything and see how the test performs in the context of the test framework that we're using. And this will invoke the methods defined by the PC client Flux, parallel flux, and PC client concurrent flux proxy adapters. And then we're going to show how they make the calls back to the server. And you can get this, again, in the EX2 project in my WebFlux folder in my live lessons GitHub repository. So here we are back in the test project, and now we're going to take a look at PrimeCheck test. Now you can see that this particular test is a Spring Boot test, and that means it's going to be able to automatically launch the PC server application, which we defined way up here. In this module, that's the entry point into the microservice under test. And we have a well-defined port here. You can see what the port is. It's going to listen on port 8081, and it's got this name. And over here, you can see that the client side is going to also know to connect to this particular port. I'm going to disable logging because otherwise it gets kind of verbose, but that can be a useful feature to turn on and off without having to recompile your code. You can do it programmatically. So we're going to have a pair of auto-wired proxy wrappers, PC client parallel flux and PC client concurrent flux. Those are auto-wired. We have something that keeps track of some parameters that we're going to pass to the actual program when it runs. Because this is a test program, there really isn't the concept of a main. So we have to manufacture our own argv field here. And we're going to disable debugging, and we're going to generate and test 1,000 random large odd integer objects. So that's how we're going to do that. We come in here, we parse the arguments. That calls up to a helper class that's going to be used to set the appropriate number of parameters and prime candidates to generate. We then use that information to generate a bunch of random integers. And you can see here that this code actually uses some Java Streams features. So this uses Java Streams features to generate random integers, where we use a random number generator to generate values within a certain value range up to a certain max value. If we're going to only deal with odd numbers, which is going to make sense for prime number checking, we will filter out even numbers and remove them and only allow odd numbers. We limit ourselves to count of these things. We box the results to be an integer, and we return it as a list. I don't know off the top of my head if there is a way to do this using Project Reactor features. Maybe at the end of this lesson, we'll see if we can cut and paste this into ChatGPT to convert it to something that would work with Project Reactor, but it certainly works with streams. So that's what I ended up using here. So we take that list of random integers, and then we're going to do a couple of timing tests. You can see we have 4 timing tests. We're going to test the individual calls using parallel fluxes. We're going to test individual calls using concurrent fluxes. We're going to test the flux call using parallel fluxes and test the flux call using concurrent fluxes. And all of this stuff calls a single time test method, which we'll look at in a second. And you can see that we pass in the appropriate method references. We pass in the appropriate flux of random integers, and then the string indicating what test is being run. So that way we can factor out common code and avoid repeating ourselves. Here's the actual test itself. You can see it takes a function, which is the method we're testing. It takes the flux of prime candidates and the name. We start out by garbage collecting everything after we print off some diagnostics to start everything running. And then we go ahead and run the test given the given function and the parameters, which is this flux of prime candidates. The results we get are going to be a flux of integer, which we collect into a list, and then we block until we're all done. And this whole thing is going to be timed so we can see how long that took to run. So that's basically the test results. And then we go ahead and display the results here, and we can see what came back. So that's kind of how things work. Let's go ahead and run the program and see what it does. Right now, I am running my laptop without having it be plugged in, so it might not run as quickly as it would run if I was testing this with it plugged in, but it'll still should still do some interesting things. And you can see here, it's starting up. The debugging code is taking place so that you know it's running as a Spring program. This is running as a test program with Spring. And you can see as it ran, it printed out what each of the calls, this is the individual calls with 1,000 using parallel fluxes, individual calls with concurrent fluxes. These are all taking place on the client side. These calls are taking place in parallel or concurrently on the server side. And you get the results back here. Not surprisingly, the ones that make individual calls are substantially slower than the ones that do the concurrency on the server side. And again, I wouldn't take these numbers to the bank because my computer's not plugged in and we'd have to run them a couple times to see how consistent the results were. But you can see that the concurrent fluxes and parallel fluxes execute in roughly the same amount of time when we're doing things on the server side. And they're substantially faster by like a factor of 3 or 4 than things that are running on the client side doing the parallelism on the client, which should make a lot of sense because after all, that's going to be paying for the round trip overhead to do the remote method invocations rather than passing everything over in one fell swoop. So that's basically that code. This will give you lots of tips that you can use when you implement upcoming versions of the programming assignments.